Assalamu alaikum. Today I would like to discuss some points related to kinetic theory of gases. These points include free path, mean velocity, mean square velocity, root mean square velocity, RMS velocity. These terms we are going to study in this lecture, in this video lecture. So we start with the first term, free path. Free path. Free path. We know that the gas molecules are always in a state of random motion. They move in the container. So these molecules between two collisions, they travel a straight path. For example, if I take this one molecule, it will collide with another molecule, and second time also it will collide with another molecule like this, and in this way it will go on colliding. So between these two collisions, it has traveled this straight path. So this straight path is called as free path. Between two collisions, between any two collisions, the molecule travels a straight path. So that straight path is called as free path, and it is represented by the letter lambda. For example, if this molecule has traveled distance lambda 1, mean free path, first mean free path lambda 1, second time it has traveled lambda 2, third time it has traveled lambda 3. So, if we want to determine the mean free path, let's define what is mean free path. It is the average distance covered by the molecule between two successive collisions. We will have to determine the average of these free paths, and that will give us the mean free path, and it is represented by the letter S. So mean free path represented by the letter S is the average of the free paths between two successive collisions. So, as per the definition, this S will be equal to average of lambda 1 plus lambda 2 plus lambda 3. In this way, as many free paths you can add divided by the number of collisions. So let it be n. So this gives me the equation for mean free path. If I say that it has undergone n number of free paths, so I can add plus lambda 4 plus dot dot dot, and the last is lambda n. So here this n is number of collisions, total number of collisions. So this is mean free path. Earlier we have seen free path. What is free path? I am repeating. Free path is the distance travelled by the gas molecule between two successive collisions. So first collision lambda 1, second collision lambda 2, in this way third collision lambda 3, and in this way the last collision we have taken as lambda n. Here lambda n. And if we find out the average of these values, lambda 1, lambda 2, lambda 3, lambda n, that average is called as mean free path represented by S. So here lambda and S both will be measured in terms of meter, centimeter or kilometer. So these are the units of free path and mean free path. So first two terms we have seen, that is free path and mean free path. Now let's go to the next term. Next term is mean velocity. Mean velocity. It is represented by the letter C bar. Mean velocity. So here we will see what is mean velocity. Mean velocity represented by the letter C bar or V bar. According to our textbook, it is V bar. Now you know that the gas is made up of number of gas molecules. They are in the state of random motion. They are moving with the different velocities. If suppose in a container I have kept a number of gas molecules, there are many gas molecules. They are having different velocities. And I suppose that the molecules have velocity V1, V2, V3, comma, dash, dot, and the last molecule is having velocity Vn. So here the first molecule is having velocity V1, second molecule having velocity V2, third molecule having velocity V3, in this way the last molecule is having velocity Vn. Now we will define what is mean velocity. So mean velocity is the average of all these individual velocities. Mean velocity is defined as the average of the individual velocities. So V1, V2, V3, Vn are the individual velocities. And if we take the average of this, we will get the mean velocity V bar. So according to the definition, V bar will be equal to average of these individual velocities. Average means what? You have to add them all. That is V1 plus V2 plus V3 plus plus Vn upon n. Upon n is the total number of gas molecules. So V bar mean velocity is equal to the average of the individual velocities V1 plus V2 plus V3 plus plus Vn upon n. Okay, now let's take the next term, mean square velocity. Mean square velocity. Mean square velocity. Mean square velocity. It is represented by the symbol V square bar. V square bar. This is a symbol for mean square velocity, V square bar. So in this case, it is again the average of squares of the individual velocities. Average of squares of individual velocities. So according to the definition, V square bar will be equal to average of squares. So we will have to take the square of the first velocity, V1 square plus V2 square plus V3 square plus In this way many velocities, and plus Vn square upon n. So here we are taking the average of the squares of the individual velocities. So individual velocities are V1 square, V2 square, V3 square plus plus Vn square. And if you take the average of the squares of the individual velocities of these molecules, that is, add them and divide by n number of molecules, we get mean square velocity. And the third one velocity, which is the last one, it is root mean square velocity. Root mean square velocity. And in short, it is called as RMS velocity. So it is root mean square. So take the short form of this. It will be RMS. R for root, M for mean, S for square. Root mean square velocity. And the symbol for this is VRMS. VRMS. Root mean square velocity. So I am going to define it. It is the square root of, it is defined as the square root of mean square velocity. Just now we have seen that v square bar is the root mean square velocity. Mean square velocity. V square bar is mean square velocity, and if you take the square root of this, square root of mean square velocity, square root is called as RMS velocity. So VRMS is equal to square root of V square bar. So this is root mean square velocity. So root mean square velocity is defined as the square root of mean square velocity, and it is given by this formula. And I can put the value of V square bar. So as per the formula we have written down for the mean square velocity, it was V1 square plus V2 square plus V3 square plus dot dot plus Vn square upon n. So this formula will come when we will derive the equation for pressure exerted by the gas. So now at the end I would like to talk about the units of these quantities. So mean free path represented by letter lambda, mean free path represented by letter S, mean velocity represented by V bar, mean square velocity represented by V square bar, and root mean square velocity represented by VRMS. So you see the unit of these quantities, units of these quantities. So lambda, as I told you earlier, will be measured in meter, centimeter or kilometer. In the same way, mean free path will also be depicted in the units of meter, centimeter, kilometer. Then mean velocity, it is meter per second or sometimes kilometer per second, sometimes centimeter per second. Centimeter per second. Then mean square velocity, meter square per second square, kilometer square per second square, again kilometer centimeter square per second square. And the last, RMS velocity. It is also measured in meter per second, kilometer per second, centimeter per second. So that's all in this lecture. Revise this. If you have any question, you can give me in writing the questions. Thank you.